Hello everyone, and a warm welcome to the UK's virtual stand at this year's Wind Energy Hamburg. We're here this year with our partners, the Energy Industries Council, the Scottish Development International colleagues, UK Export Finance, and the wider UK Offshore Wind Network. This year we will be focusing on three key areas, giving you some true highlights of UK expertise. In this session, we'll be looking at floating technologies. Worldwide, 80% of the offshore wind opportunity is thought to require floating solutions. The UK has an ambition to build on its existing floating wind farms to deliver 1 gigawatt by 2030. There is a wide range of companies working in this area, and this webinar brings 8 together to look at various issues and solutions when developing floating wind farms. We hope this will be of interest to organisations around the world that are at different stages of delivering their own floating projects. So I'll hand over now to Bruce Clements, DIT Offshore Wind Specialist, who chaired the session.
Thank you. The selection of companies is a good selection, but it's not meant to be a definitive set of companies by any account. They are part of a much wider selection of companies, drawing from areas such as oil and gas, marine, subsea, and obviously fixed bottom offshore wind. The 8 companies today are as follows: Wood, Atkins, Ryden Beckhardt, First Subsea, Trelleborg, Global Marine, London Offshore Consultants, and Strainstall. Floating wind is obviously going through a lot of development at the moment, and this makes it a very interesting and exciting sector, and it will be great to hear what the companies have to say today. Let me introduce you to Alan Mortimer from Wood. Over to you, Alan.
Thank you, Bruce, and very brief introduction to Wood. We're a large engineering and project services company, 60,000 staff, largely engineers, working in 400 offices around 60 countries. And since acquiring AMEC Foster Wheeler 3 years ago, hugely diversified into all of the energy and infrastructure sectors. Click. Thank you. Offshore wind is an important sector for us. We've worked on 100 offshore wind projects to date. That's 50 gigawatts, with involvement in over 70% of Europe's offshore wind projects and 75% in Asia Pacific, including some of the world's largest. And in case of floating wind, we've worked on the world's first commercial floating wind farm at Scotwind, Scotland. We're also working on the world's first floating wind platform electrification project, which is Hywind Tampen in Norway, on the EPCI of platform electrification. Okay, click. And we're asked to focus on one thing, so I've focused on delivery partner role, which is cheating really, because it covers everything. But in the case of floating wind, it's split into a number of packages, as you can see, and in totality, a very broad range of skills, expertise and resources required to deliver. And although there are discrete work packages, actually they are all interrelated, and managing the interfaces through the project is a key skill. Click. So I'm just going to touch on some of these areas of expertise. First of all, site selection and consenting, very live at the moment with the likes of Scotwind. And this shows here the offshore wind projects where we've been involved in site selection and EIA consenting work to date. Also DCO experience, which in the UK is particularly relevant. Click. Engineering, procurement and construction. Click. And project delivery in many sectors is what we do. So it's following through from the early stages: feasibility, pre-feed, feed, procurement, construction management and commissioning as well. And in offshore oil and gas, particularly relevant, I've picked out 3 projects here. Clare Ridge for BP, that's west of Shetland, Cygnus for ENGIE in the southern North Sea, and the Knightsbridge floating project in the North Sea as well. Click. Offshore substations, and these are all for or related to offshore wind. So roles there involving design work, concept review, and construction and fabrication management. So examples are Sheringham Shoal, Darwin 6 and Empire Wind. Click. Subsea cables, and in this case working on route selection, consenting, landfall, and problem rectification as well, and again management. So examples include London Array, Hornsea 1 and the Airgrid East to West HVDC interconnector. Click. Platform electrification, and in the offshore energy transition, this is starting now to play a key role. But actually, we've been doing it in oil and gas for a while, and more recently now in Tampen in relation to floating wind. So the roles there include design work, EPCI actually that we're doing for Tampen. So we're providing the modifications to the platforms and the tie-in to the floating wind turbines. So there's Tampen in Norway, Eldfisk, and Sakhalin, which is in Siberia. Click. Innovation also has a key role to play for floating wind. I think, in fact, a very important role to play in driving down the cost. And we are already involved in a number of activities, including the world's first scanning LiDAR on a floating wind turbine. That's Hywind in Scotland, and the trick there obviously is motion compensation because the turbine is moving. Platform optimization, and definitely the biggest area for cost reduction is in the platform. And after reviewing the concepts, looking at the leading ones, we can see potential route to driving down costs, both in design, but not just design for use, but design for manufacture as well. And that's going to be a big area of focus for the next few years. Wind Resource 2, and there we use a combination of LiDAR measurement and CFD modelling to understand what's going on and to optimally design projects, looking at effects including blockage and wake interactions, extreme shear, gust tracking and so on. And because of the dynamic nature of floating wind, there's actually a lot of scope here to help drive down costs by smoothing out the loads on the turbines and on the platforms. Okay, click.
30 seconds, Alan.
Okay, click. I'm on the last slide. So floating wind sector is rapidly gathering momentum. Engineering and manufacturing solutions are going to drive down costs, both in the floater and the turbine and the way they're integrated. In manufacturing and design for manufacturing for volume production, in the moorings, dynamic cables. And I would say especially in floating wind, and it's probably a theme from others, success in this sector requires building on expertise from both the established offshore wind sector and from oil and gas. And it's a combination of both that's going to get us to where we need to be in this sector. So Wood offers a delivery partner role, combining that cross-sectoral expertise. Thank you.
Thank you very much, Alan. And now moving on, I would now like to introduce you to Kate Rudman from Atkins.
Thank you. Hello, my name is Kate Rudman. I'm an engineering manager and principal engineer with Atkins. My background is oil and gas, and I've been in offshore wind since about 2014, during which time I have undertaken 4 secondments into owner engineer roles, including Blythe Offshore Demonstrator Project, and most recently, an offshore floating wind project in South Korea. Today, I'm going to talk a little bit about the company, what we've done in wind, what we're doing in floating, and some of the lessons learned from floating. Click. Atkins SNC Lavalin is an international engineering company with about 50,000 employees. As you would expect, our offices are global, and we will often team up with local offices for projects as required. Click. Click. We've been in offshore wind since about 2002, the first project being the Beatrice Demonstrator Project. And since then, we've been involved in about 60 offshore wind farms, including 11 floating projects. Click. We have expertise over the entire life cycle of an offshore wind project, from site selection all the way through to life extension and decommissioning. The slides will be passed out after. I appreciate this is quite a busy one, but I'd like to draw your attention to 2 points. So the first one is geotechnical. We get a lot of support from our geotechnical teams, and geotech is a really important part of all offshore wind farms. And the second one being the post-installation asset management, where we help clients assess risk and keep structures with defects going. So essentially, Atkins is a one-stop shop. Next. Click. Since about 2008, we've been involved in floating wind, building on expertise from oil and gas and transferring knowledge into floating offshore wind. Click. Within floating, we've been involved in 3 main areas: design, owner's engineer, and consultancy. Click. Design can be anything from sort of pre-concept and typically runs through to fabrication support. And during these stages, this is where we do a lot of the problem solving and consider the potential load cases over the life cycle, including transportation, operation, and maintenance. Atkins have a strong record in floating design, including Windfloat, Kincardine, Highwind, and Hexagon. Click. Owner's engineers are where we either put people in to support a client or developer, or we put a whole team in. Then these teams help out on the projects to manage the interfaces, do the design and work package management, procurement for these projects. Additionally, we often support with design review and putting SMEs or subject matter experts in to help a team. I've put a picture of Blythe in there. It's not truly a floating project, but it floated out, so I thought it kind of counted. Click. Consultancy, this for me is where we sort of roll all the clever engineers out of the cupboards to solve quite tricky problems. And so they'll use the in-house tools and do some advanced analysis. Click. So what have we learned? We've learned about weight savings. Now, weight savings are going to be important on any offshore wind project, but particularly with floating. And this is going to become even more important as we move to larger projects and more commercial projects where weight savings on a single unit then goes over the whole wind farm. So that's quite an important part. But for me, I think the most important thing that we've learned about for floating is collaboration. Now, collaboration is important in any project that you guys have worked on or I've worked on. But I think particularly in floating, because the structure is so integrated and it's so integrated with the cables and the mooring and the geotech, it's even more important to get everybody on board early. It's really important to get your foundation contractor, design contractor, working with your WTG manufacturer and really getting that coupled analysis going quite early, because you're going to need a couple rounds to get the optimization. And that might even lead to different approaches in your contracting. I think it's also really important to get involved with those specialists early, especially around sort of the cables and the mooring and the anchoring. And then that leads to also then needing to determine quite early your O&M philosophy. So you really want to bring that to the front so that you're thinking about all of this as a holistic, integrated, and really start talking to those companies early and getting everybody involved to help problem solve. And I think with the increase in O&M as well, there's a real opportunity to increase monitoring, because the more monitoring you put in, the more data you're going to have, and the more you're going to be able to solve from the shore without having to send people offshore to get data or to do inspections and so on. So for me, it's really about, using the knowledge from previous projects to get those weight savings and the collaboration. Click. 30 seconds. So, no problem. So what are we still learning? There's still obviously lots of room for optimization. And what I think we're going to see is some really good innovation around installation. So that's installation with the inter-array cables, installation with the mooring lines, whether they be catenary or TLP, all tied in with whatever your O&M philosophy is. So I think we're going to see some really cool quick release things, some retensioning things, but I also think we're going to see innovation in project programming because you're not dependent on that heavy lift vessel. So you've got time. So I think we might see some innovative approaches to how you actually program your project. And then I think the area we'll also see innovation in is major component replacement. So just like fixed, what floating needs is security and consenting and financing to bring it to the market. We have the technologies, and we will see more and more innovation as the projects become larger and as projects complete. Thank you very much.
Thank you very much, Kate. Just moving on. So that's Atkins. So click, please, Jamie. Yes, I'd now like to introduce you to Nicola Bruce from Brydon Beckhardt. Thank you very much, Nicola.
Hi, everyone, and many thanks for giving me the opportunity to speak during this live event. So I'm Nicola Bruce, a Business Development Manager Renewables for Brydon Beckhardt. And if we are here today to speak about floating winds, and one of the characteristics of floating wind platform is that they are not boats. You don't want your platform to travel or to drift during operation. That's why you need and you want your platform to remain safely at a precise position using a simple and easy installation method. So what I will do first is introduce you Brydon Beckhardt. Thank you. So we're part of the Beckhardt group. Beckhardt is present in over 120 countries with a 5.1 billion turnover in 2019, and we are over 30,000 employees. You can click, please. So we are one of the unique company who can present under one roof every mooring solution from steel wire ropes to synthetic ropes. And also we can be with you from the design to the installations. So we have steel spirostone ropes, nylon ropes, polyester ropes, H&P ropes, and I will show you in detail later. If you can click, please. So innovation is in our DNA. You can see here different initiatives we have today in the floating wind world. And also you can see some picture of our innovation center in Doncaster. But we have different innovation center around the globe. If you can click, please. So our experience, like most of my colleagues here, was made in oil and gas. And for us, it was deep water mooring installations. But oil and gas is not floating winds, where we come from one big barge with 16 to 20 mooring lines up to 3 kilometers long. Here we have a constellations of small barges in relatively shallow waters, and you can imagine the number of mooring lines you need for a floating project who have like 20 to 30 wind platforms. So today our challenge is to reply to your question about what the behavior of the rope in shallow waters can be for polyester, but also more and more question about nylon ropes and also high modulus ropes. But the steel rope still remain very strong today in our industry. You have to have a system worry-free for 20 years. We have all the question about how can we reduce LCOE. So for us, low cost, but low cost in terms of installation, also production, and for you to remove a very expensive part like heavy vessels or tensioning method, etc. Also, an important part is, as I mentioned, for a big farm, you need up to 200 to 300 lines with splicing or socketing, which means you need to be ready to scale up. And in Brydon Beckhardt, we have this ability to scale up, and we are already ready for commercial wind farm projects. Last but not least, also we are working hard on how we can have local content involvement on the different projects. If you can click, please. So one of the big projects coming is the Scotwind. As you can see, local content here is very easy. We have 2 factories in Scotland fully dedicated to synthetic ropes. We also have in UK, in Newcastle, our factory for spiral strands, so steel wire ropes. But our group is global, and we are also working on how we can implement local content like in France or every part of the globe. So if you have any question about your mooring system, please contact us. I will be present in Marseille for the Floatwind event. Also, stay tuned. We have some very big announcements this week, so you will hear from us in the coming days. Thank you very much.
Thank you very much, Nicolas. I would now like to introduce you all to Greg Campbell-Smith from First Subsea. Thank you very much, Greg. We can't hear you, Greg.
Sorry about that. We're First Subsea is a specialist niche contractor for mooring components in floating offshore wind. We're quite fortunate that we've been involved in a number of projects now. So the presentation that I'm going to give to you today is going to be looking at a specific problem and a solution that has been derived specifically for floating offshore wind. Click. First Subsea manufacture connectors used to connect the mooring line from the seabed to the structure. Typically, in some of the larger oil and gas platforms that we have previously moored, we've centered around the actual connection of the mooring lines at the seabed. But as we were developing our solutions specifically for floating offshore, we looked at the cost and we looked at the technicalities of mooring a floating offshore wind platform and how you would actually make the connection between the seabed and the actual platform. So traditionally, chain tensioners, lockers and fairleads or assemblies are used, and in the picture there you can see some illustrations on a Japanese project showing the chain tensioners, fairleads that were used on the very first projects in Japan. And what typically you find with these type of systems is that they are quite very expensive because they're based on permanent oil and gas facilities, so they for the cost is quite prohibitive for the levelized cost of energy. Plus the association of fairlead chain wear and other issues that have been common through oil and gas are probably more prevalent because you're in shallower water, therefore you're seeing higher frequencies and then you're going to have more fatigue potentially occurring in those areas. And also the actual time taken to make the connection was quite high. So First Subsea was initially started working with the company, specifically looking at how to make the connection at the point where the fairlead will be. And over a period of 5 years, we've developed a system which now allows the connection to be made actually at the hull. We've removed the need for fairlead sheaves, we've removed the need for chain tensioners and chain lockers. By doing all this, we've certainly improved the system from a fatigue perspective, but we've also improved it from a hookup time cost. And the cost associated with the vessels, specifically, you've no need to have some of the larger installation vessels that you may have seen traditionally with some of the larger floating structures used in oil and gas. So we believe that we've made certainly a large improvement to what was previously adopted in oil and gas methodology that was initially transferred over to floating offshore wind, and we've come up with a solution which is cost effective but also very quick to assemble. And if you're looking at the fields of between 25 and 50 floating offshore units and anywhere between 3 to 6 marine lines per offshore floating unit, we believe that the connection time is also of importance, because you're going to reduce your overall capital expenditure cost if you can do it quickly as well. So click. Here's just a quick indication of the cost associated with the different levels of engineering. We did have a cost for the chain tensioner or in excess of over $100,000, a fairlead stopper between $50,000 and $100,000, and a fairlead sheath over $100,000. These are elements that you would have to have if you follow the oil and gas model. But by adopting a solution specifically designed for floating offshore wind, we believe that we've come up with a connection system that meets the need of the floating offshore wind market. Click.
30 seconds, Greg.
Yep, click. So just a very quick overview. The PMC installation is very straightforward. You pull the connection from the seabed and it connects into a female receptacle which is on the actual platform. This is now a proven technology. It's approved by third-party classification societies and conforms to all the marine regulations. And then just the last slide, please, click. Just a quick review of First Tech. We're a small company. We have a very large experience. We work on providing solutions. We're very experienced in offshore wind, and if you've got any inquiries, as Bruce has mentioned at the beginning, please feel free to contact us. Click. So the contact details are at the bottom of the screen. Thank you.
Thank you very much, Greg. That's great. So now let me introduce you to Andy Smith from Trelleborg. Over to you, Andy.
Thank you very much. Hello and welcome everybody. I'm Andy Smith, the Product Group Manager for the Trelleborg Applied Technologies Division of Trelleborg Offshore UK Limited. I look after all of the non-oil and gas business for the group, majoring on the renewable energy sector. Click. As you can see on the slide here on the left hand side, we have a small image of a floating offshore wind turbine. The dynamic motion of this floating offshore wind turbine due to the waves and currents induces bending and tension into the power cable that you can see hanging down underneath the floating offshore wind structure. This induces bending and tension into the power cable. So what happens when this thing is bobbing around in the sea is that the motion of this cable can produce unacceptable tensions and strains and fatigue into the power cable. So what we do is we introduce additional cable length into the system and attach distributed buoyancy modules, as you can see on the left hand side, onto that power cable to introduce extra length to prevent any additional tension becoming in the power cable. If you look at the graphic on the right hand side there, you can see the top image shows the additional cable length with the buoyancy modules in position, and the one at the bottom is a cable configured with an increased tension at the bottom, which basically means that the power cable can become overstressed. We also provide dynamic bending stiffeners between the junction with the floating offshore wind structure and the power cable itself as well, to reduce the overbending in the cable at that fixed point. Also, we would provide Euroduct touchdown protection where the power cable meets the seabed. Next. Okay, so the solution is to attach distributed buoyancy modules onto the power cable to produce a floating section of power cable to ease the tensions in the cable. The distributed buoyancy module is a packet of buoyancy that is attached onto the power cable with a class-leading internal clamp. The internal clamp is shown on the bottom left-hand side. It's a nylon body with some rubber fingers on the inside, and this has been designed specifically for cable and umbilical applications. It can present an axial load capacity of up to 1,200 kilograms of uplift, and is compliant with a 10mm diametric contraction. We also have many different types of other internal clamps as well that we can offer, and we also have integral buoyancy modules which doesn't have an internal clamp, which speeds up the installation process that little bit further. Over on the right hand side there you can see one of the internal clamps with some of our installation tooling. It's very lightweight, it's very quick to install, and we can install these buoyancy modules in under 5 minutes. Click. Okay, the other thing I mentioned other than the buoyancy modules was the dynamic bending stiffeners. Trelleborg Offshore UK have over 20 years of track record, mainly from the oil and gas sector, for dynamic bending stiffeners. What the dynamic bending stiffener does is it attaches to the underside of the floating offshore wind structure, and it interfaces with the structure to prevent the large differences in stiffness. The cable is relatively flexible with low stiffness, and the floating offshore wind structure is very rigid. So this works the same as the small bend stiffener that you might find on the end of your power cable from your electric kettle, for example. So this maintains the cable integrity at these interfaces and controls the bending of the riser, and ensures that the minimum bend radius of the power cable is not exceeded at this interface. Trelleborg Offshore UK Limited has supplied over many thousands of dynamic bending stiffeners into the industry over the last 20 years. We have third-party approval.
30 seconds, Andy.
Okay, thank you. We have third-party approval and conform to API 17L1. To date, we've had no in-field failures, and we also have a diverless connection which can be installed and removed using ball and taper technology, which is also DNV qualified, and you can see this on the Highwind project over on the right hand side there on that image. Next. This is the last slide, and this is showing a montage of all of the projects that Trelleborg Offshore UK have been involved with. There's a list there on the right hand side, and we have products on Highwind, Windfloat, Fukushima, Highwind, Scotland, Hibiki, Kincardine, Windfloat, and Kincardine 2. So we have these products installed on every different type of foundation for floating offshore wind. Click. Okay, that's me. Finished my presentation, and also at the show in France, our contact Etienne Lair, who's our country sales manager, will be present at the show. Thank you for listening.
Thank you very much, Andy, for that. Okay, now moving on, let me introduce you to Ali Lawson from Global Marine. Thank you very much, Ali.
Good morning, everyone. I'd just like to introduce myself. I'm Ali Lawson. I'm Assistant Project Manager for Global Offshore. I've been working in the renewables industry for 10 years in both project management and engineering roles. The topic I'm going to be discussing with you today is the design and installation of the cable containers and floating offshore wind farm. Next slide, please. So just to provide a brief overview of Global Marine Group. The group is split into 3 brands. There's Global Marine, which deals with the telecom side of things, Scotwind, which deals with CTVs and cable poolings and renewables, and Global Offshore, who I work for, deal with cable installation and burial in both oil and gas and renewable sectors. And of course, we've got shared services for the group, which are spread across the UK and throughout the world. Next slide, please. So what I'm going to give you an overview of is one of the main challenges for the subsea cable installation contractor in floating wind farms. And this is the installation of the dynamic cable catenaries into the floating structure. So essentially the cable that is in catenary between the floating structure and the seabed. And this is the case for both export and array cables. Some of the factors to consider include deeper water depths. Most of the industry to date is in relatively shallow water depths, say typically 20 to 40 meters, whereas floating installation could be in far deeper water depths. Currents are a big variable to consider. Does this impact on the design of the cable catenary? What installation challenges does the current pose? Mooring chains are thought are something to consider in relation to vessel positioning and ROV excursions and cable poolings. Floating structure versus fixed foundations. There are many differences in the installation methodology. For example, whether it is an aperture in the monopile versus I-tubes on the underside of the floating structure. Difference between cable designs, whether you need additional armor layers, differences between CPS designs. There's a number of things to consider with the two different types of structures. The cable catenary design itself, design considerations for the cable catenary, for instance, stability, buoyancy, and fatigue assessments. We've also got things like the deck handling and installation of the cable accessories, including the storage of these items on deck. Something else that we consider is the cable pooling methodology. Where is it possible to position the winch on the top side for the cable pooling? And all the interfaces related to the top side operations. There are a range of other factors to consider as well. And we've got here an image on the right. There is the Global Symphony having completed the export cable installation on Kincardine offshore wind farm in Scotland. Next slide, please. So to overcome these problems, we have implemented some of the following measures. Design analysis for floating cable catenaries. This is the design for the catenary in its as installed condition. A little bit which has been touched on already in some of the presentations, and taking into account sort of the met ocean data for the site. You know, all the environmental conditions have a big factor at play. We've got design and manufacture of buoyancy modules and bend stiffeners as required, so we'll be working closely with some of our supply chain. You can see from the two photos on the right hand side, I'm sure they won't mind me mentioning them. The top right is Trelleborg's buoyancy modules, the bottom right is First Subsea's bend stiffener. These photos have been taken during the deployment from the Global Symphony on Kincardine. One of the next steps is to develop the installation methodology and procedures, and how we're actually going to install the cable catenaries themselves, overboarding techniques, could we use 2 work-class ROVs, all that type of thing. Following on from that, there is the engineering installation analysis, and ensuring that the cable's integrity is maintained throughout the operation and life cycle. You can see an image of an Orcaflex model on the bottom left-hand side of the slide. And then finally onto the actual installation operations themselves. Next slide, please. And I just wanted to give you a little bit of an overview, following on from the cable pooling on Kincardine floating offshore wind farm. We conducted an as-built ROV survey, and the results of this can be seen on the right-hand side. So a plying wave has been formed as per the intended design. To explain a lot about the elevation drawn here, starting from the left-hand side, the cable on the seabed is in touchdown. There's a little bit of cable protection there just to guard against fatigue. Buoyancy modules were assembled on the product to form the pliant wave in the water column. This is the top of the arch. There's then a sag bend was formed to protect against any dynamic movements, and the cable runs through the bend stiffener that is installed in the I-tube within the floating structure itself. The next phases would then be the testing and termination works and burial operations to be undertaken as required. Next slide, please.
30 seconds, Ali.
No problem. Thank you very much for listening. That was just a very brief overview, but if you do have any questions, please do get in touch with either myself or Keith Pomfret, either by email, which you can see, or through LinkedIn. Thank you very much for your time.
Thank you very much, Ali. So, okay, so let me now introduce you to Peter Kroll from London Offshore Consultants. Thank you, Peter.
Hi, good morning, everyone. I'm Peter Kroll. I'm a Renewable Technical Director at London Offshore. I've been involved in offshore renewables since 2007 and with LOC since 2012. Click for the next slide, please. This shows the LOC group track record. So LOC is made up of 3 key companies. So there's London Offshore Consulting, there is Innosea, which is a company in France, and Longitude Engineering, which is an engineering consultancy. This shows between the group which floating wind farms we've been involved in and whether it's been as a marine warranty surveyor, providing advice, providing engineering analysis, or design and early stage, or we've had some involvement with maintenance planning as well. Click for the next slide, please. This slide shows you a lot of the activity that Innosea, our company in France, have been involved with, very much on the design side and the support to people through design, integrating the turbine to the floater models, doing some resource assessment, looking at the control modes that are required, and moorings design and umbilical design for the cable risers in the early stage, determining sizes, capacities, this kind of activity. They're also quite involved in helping to get approvals in place in France. Click for the next slide, please. This is what I would like to more focus on today, which is our involvement with Windfloat Atlantic project for the 3 floaters off there. We were engaged for early advice, and as we are a company made up of people with practical marine experience at LOC, we tend to be heavily involved in the transport and installation of the equipment offshore. So for the 3 floaters that were used for Windfloat Atlantic, there was some different marine challenges for each one. So the first floater to be integrated with the turbine was constructed in the dry dock in Ferrol, trailered onto a heavy lift vessel, which was then floated off into the harbour in Ferrol, tied up alongside for the turbine to be constructed on board. And there was quite a few issues with doing that. Actually building the towers and the turbine onto the floaters is a challenge all in itself, with floater movement, as you can imagine. Also, one of the challenges that a lot of people are facing, unless you happen to be in Norway, is getting available water depth at quayside to be able to install towers and turbines in a sensible port, so you can end up with long transit times. And then this also leads to you having to plan carefully your marine operations to ensure that you maximize your time for installation offshore and minimize the assets. Click for the next slide, please. So we were heavily involved, so we provide early stage advice using a combination of naval architects, master mariners, marine engineers and marine installation teams to help, as well as provide MWL services. So we provided assistance throughout the SPMT loadout, the transit along the river and the float off to ensure it was optimized. So applying sensible rules as MWS to make sure that the insurance policies were all in place, but the activities were optimized and there was no over engineering involved, so that the operation could be done quickly and sensibly. One of the challenges that was found in Ferrol for Windfloat was the harbour entrance was quite wide, And so with the wrong wind and wave directions, the swell that was in the harbour was enough to cause issues with trying to land the towers and the nacelle and then insert the blades into the nacelle. We worked with Windflow and Principal Power to ensure that a solution was found to optimize doing this through winter, which resulted in grounding of one of the floaters alongside the quay, using the ballast systems. We worked with them to plan the ballast operation to maximize it through the tide, using our experience of, well, in effect, jackups and grounding cable barges to provide analysis and assistance so that the operation could be completed successfully. Click for the next slide, please.
30 seconds, Peter.
Great, thank you. And this last slide covers Longitude Engineering activity, who are heavily involved in the use of Orcaflex for analysis of moorings and cable installation and dynamic riser design. And they can assist, and what we've used them for assistance for in these kind of operations is when you're hooking up 3 moorings and you need to maneuver the floater into position. We're heavily involved in the planning of that and sorting out the vectors to minimize the loads on the moorings so that you can pull in the nice PMC connectors that we saw earlier. Click for the next slide, please. So this covers our range of services within the group that we can offer. I think LOC currently employs about 300 technical professionals in over 30 countries. Click for the next slide. This shows a whole list of things that we are involved in. Click for the next slide, please. And this shows the countries we have offices in. And what that shows is we're currently involved in offshore wind throughout the world, including heavily involved in Taiwan, Korea and Vietnam. Click for the next slide, please. And there's our contact details with our various companies. Thank you very much.
Thank you very much, Peter. That's appreciated. So now, just moving on to the final presentation, let me introduce you to Michael Hook from Strainstall. Please note that this is pre-recorded, so there may be a bit of distortion. Thank you.
Hello and welcome. My name's Michael Hook and I'm pleased to be part of this DIT webinar today, talking to you a little bit about how we've become involved with the floating offshore wind sector, and pleased to say we form part of that supply chain and now actively supplying into a number of projects. So what is it we're going to talk about with regards to Strainstall? We were asked to give a bit of an insight into a project that we've already worked on with the hardware that we develop and supply for monitoring of mooring loads. So traditionally, I guess people would expect mooring load monitoring to be undertaken using shackles or load pins. For the Highwind Scotland project, we were approached by McGregor Busnets, who are obviously a very established supply company within the oil and gas sector, and said to us, you guys have been around for a long time, you've supplied hardware and whatnot for the best part of 60 years, what have you got that can help us with this? And we explained that for the purpose of this project, we could actually supply our patented strain ring, which unlike a traditional load pin or a shackle, does not form part of the primary load path. It is in fact bolted onto, in this case, their chain connector, which enables us to measure the strain that's being imparted on the connector, which then enables us to resolve what the load is. There are many advantages to this. One is obviously it doesn't form part of that primary load path, which if it doesn't sit in that load path, it doesn't have to be engineered to such a scale to be able to monitor the loads. They're also incredibly accurate, 0.25% of full scale. So that meant that the accuracy of the data that was being collected was really good. And what is it they were actually looking to use this data for? Well, ultimately, it was about having something that could feed into the development of their platforms going forward, validating the design versus real life loads, and then ultimately, hopefully, forming part of a method to value engineer and re-engineer as they go on to the Hywind Tampen project and such like. But in the wider context, what is it going to be used for? Well, we would think it's about data validation, live operational information, and ultimately, monitoring of the performance of the mooring arrangements, which are going to bring significant safety and security benefits to a high value asset. The strain ring itself, as I'll show you in a second, has been used extensively within the oil and gas sector. But we're pleased to say that having done the Hywind Scotwind project, we have now worked with First Subsea, who I believe are also on this webinar, where we've attached strain rings to their platform mooring connectors, which are being used on the Kincardine project. So we're certainly seeing the ability to take a proven oil and gas piece of hardware and actually transpose it across into floating offshore wind. So the strain rings, as I say, they don't form part of the primary load path. They're designed for something in the order of 20+ year life, able to be fully immersed and can be either put on as new or retrofitted. So in this particular instance, you can see the strain ring shown here in the engineer's hand being retrofitted onto a chain connector. In this particular case, the semi-submersible had an old load monitoring system that was no longer working. They weren't able to put a pin or a shackle in or anything like that. So they approached us, this was Blue Water, and said, well, can we put a strain ring onto a connector? In this case, we put one on either side so you could see out of plane bending moments and ultimately then be able to resolve what the load is that's being put through that. And this was used as part of an asset extension project, but exactly the same technology and concept that is being used on the floating offshore wind projects that we're talking about these days. So just moving away from hardware for a second, where do we see the data? What's it used for? Well, phase one is what I think many developers are right now. They're using data to validate their models and look at the R&D and value engineering going forward. I think then as we move into phase two, and you could argue that maybe one or two of the developers, technology developers, are now at this stage, it's about asset integrity, the ability to ensure increase the levels of cover, and ultimately improve the operation and reduce the cost. LCOE is obviously the big driver, and then that's where phase three is, where you're then looking at, can we reduce the OPEX by less time on site, using digital twinning, all stuff that Strainstore and the wider James Fisher Group is able to deliver. That's quick, but I hope that helps. Please feel free to contact me on any of the details shown there or download our white paper. Many thanks.
I hope you have found this session useful. It is just one of the 3 sessions, so stay with us for the highlights on digital technologies and floating wind. On this site, you can download the UK Pavilion brochure at the Wind Energy Hamburg 2020, where our contact details are available, as well as here.